Today's lessons we will be talking about a function and what makes a function. When you talk about a function, you want to say that every x from the domain will be assigned to one and only one y value. In other words, this equation, this relation, must pass a vertical line test. The x cannot repeat itself. We will be visiting domains, the set of all x values, these are your independent variables, and your range, the set of all y values, this is your dependent variables. So let's take a look at your parabola. Your parabola, your quadratic, is a function. It passes a vertical line test. Its domain is all real numbers. Every x is assigned to one and only one y. Its range is from 0 to infinity. You will never get a negative when you square a number. To test your equations, you need to solve in terms of y and ensure that every x has one and only one y value. In other words, if you have a y squared and you have to undo that square with the square root, when you take a square root, you get a plus and a minus. So say for instance x was 1. You would get a 1 and y could be 1. You would get a y of negative 1 as well. So this x is assigned to two different y values. This is not a function. So let's take the first one and solve in terms of y. Let's divide by 2. And what you have here is your basic parabola with a couple of transformations in it. But yes, this guy's a function. B, on the other hand, has your y squared in it. So when we get down here and we divide by 2, we're still left taking the square root of this. And when we take the square root, we get a plus and a minus. And that gives you two y values. That gives you two y values for one x. That is not a function. Letter C, we have your absolute value function. Passes a vertical line test, and that is a function. Letter D, however, is a sideways absolute value function. And why this happens is because if a value of x, say it was 3, it could be assigned to a negative 3 of y, because absolute value makes it positive, or it could be assigned to a positive 3 of y. So one x will have two different values for y. We will also be visiting your function notation. F at x is read just that, f at x. We sometimes say f of x because it's function f for the value of x. When we evaluate your functions, we're essentially evaluating the y value at that given x. So we're going to plug in your x value and find its corresponding y value. These three functions are just named by different letters. So when we start doing our function notation, we find function f, and we replace the x in function f with a 3. So here is my x in function f. So I'm going to say 2 times 3 plus 4. And this resolves to 10. That means when I plug the x of 3 in, the value when x is 3 is 10. For my g function, I'm looking at an x of 2. So I plug in 2 for x. So I'm going to get 2 squared minus 1. This will give me 3. In my h function, notice we have two places where x appears. You have to plug them into both places. So 4 squared plus 2 times 4 minus 1. This will give you 16 plus 4 is 24, minus 1 is 23. So an h at 4 is equal to 23. A composition of functions involves the f of g, g of f. You can string 3 of them, and these are not commutative. So f of g of 2 and g of f of 2 are two different compositions. To do a composition, you always start at the right. You resolve that one first and you scroll it over to the left. So let's put in a g of 2. We look for our g and we say 2 squared minus 1. This gives us 3. So we're going to roll to the left and put the 3 into the f function. And we're going to get 2 times 3 plus 4. This will give us 10. So our composition of f of g of 2 is equal to 10. G of f of 2 says start with the f of 2. So we're going to get 2 times 2 plus 4. We're going to get 8. We take the 8 and we roll that into the g. This will give us 63. Notice these are not the same. This is not a commutative property. If we have 3, we still start at the right and we keep going left until we resolved our whole composition. So we start with h of 2. So we have 2 squared plus 2 times 2 minus 1. This will give us 4 plus 4 is 8, minus 1 is 7. We take that and we roll that into the f. We just keep moving to the left. So 2 times 7 plus 4. This will give us 14 plus 4, 18. We continue and we roll it to the other one, to the g. G of 18 gives us 18 squared minus 1. This will give us 323. So the composition of g of f of h at 2 is equal to 323. Sometimes we do a composition in which we need to find the equation, the rule of this composition. Again, you start at the right. We will roll the equation of g of x into f of x. Easiest way is to write the g of x first. And we're going to roll this into your f of x. You take the entire g, you locate the x in the f of x, and you move that into there. The 2 stays, the x comes out and is replaced with x squared minus 1, and the plus 4 remains. And then just collect your like terms. 2x squared minus 2 plus 4, 2x squared plus 2. If we went back and we now did f of g of 2 that we did above, we could just replace the 2 right here into one rule and come out with the same answer. 2 squared is 4 times 2 is 8 plus 2 is 10. And if you remember, that's what we got up here. G of f of x says start with the f of x and roll that into the g. So we're going to start with your f of x. We're going to put it into your g of x. Take the entire equation and replace this x. Notice the square still is there. You're going to have to FOIL this. 2x plus 4 times 2x plus 4, and you still have the minus 1. This gives us 4x squared plus 8x is 16x plus 16 minus 1. So 4x squared plus 16x plus 15. So our rule for g of f of x is 4x squared plus 16x plus 15.